Welcome to sorry. Hello, welcome to video 39. I am Mr. Cozy, and today we are going to talk about how to combine two functions together. Specifically, we'll look at adding, subtracting, and multiplying functions together, and we'll look at the domain of the result. So let's get started. Okay, we're going to look at four functions. Here we go. F of x is 3x plus 2. G of x is x minus 1. H of x is the square root of x minus 1. And L of x is the square root of 5 minus x. Okay? And so we want to combine these together. Let's talk about adding and subtracting. If I want to do something like f plus g of x, it's really simple. I write out f of x, I make a big old plus sign, and I write out g of x, and then I combine like terms. So f plus g of x is this, which works out to be 4x plus 1. Same thing for subtracting. If I want to do g minus f of x, yeah, I write out g, make a minus sign. Now, because I am subtracting this whole function, I need to put it in parentheses, so that I can simplify it. Flip signs and add. So I'm going to get x minus 1 plus negative 3x minus 2. This is going to give me negative 2x minus 3. Okay? For multiplying, if we do f times g, or fg, I would write out f, write out g, and multiply them together. So here I need to FOIL 3x squared. My outer is negative 3x, my inner is positive 2x, so minus x minus 2. Okay. Now, if you notice, I have been leaving out h and L. I can also add and subtract or multiply things with radicals in them. I just need to be aware of the rules for radicals. So, for instance, if I want to add f and h together, I'm going to write out f, which is 3x plus 2, make a plus sign, write out h, which is square root of x minus 1, and this is all I can simplify. There isn't anything more that I can do to simplify these. Okay? Because these are under the radical. Well, actually, I can't, because radicals generally do not play nice with adding and subtracting. This is done. And even if I want to add or subtract two radicals together, like h minus l, I can write out h, write out l, and subtract them. And this is really all I can do. This is as much as I can simplify it out. Now, I do have a few more options. If I multiply h with L, h times L, it's going to give me a square root of x minus 1 times square root of the 5 minus x. And remember that when you multiply radicals, you can multiply what's under the radical. So I can do this. And then if I wanted to, multiply it out. Okay, I think this works out to be, actually, you know what, I'll just leave it here. I would multiply this out if I wanted to, and that would be my my answer. Okay, so adding, subtracting, and multiplying two functions together is pretty easy. It's very intuitive. Let's talk about the domain of the result, because here's the thing. F is a function, so it takes x's and churns out y values. G is a function. It takes x's and churns out y values. So if I add f and g together, my resulting function can only accept x values that work in f and in g. Okay, if there's an x value that doesn't work in either of these two component functions, it can't work in the result, because this is f plus g. What I'm doing is I'm taking f, getting an x or a y value out of it, taking g, getting a y value out of it, and then adding them together. So I can't give either f or g numbers, x values that they can't take. Now, in the case of f and g, it's not that big of a deal. F has a domain of all reals because it has no radicals, no fractions. G has a domain of all reals because it has no radicals or fractions. And because f and g could take anything, f plus g, g minus f, and fg can also take anything. So each of these has a domain of all reals. It gets a little hairier when we look at f plus h, because while h has a domain of all reals, while f has a domain of all reals, h is a square root. And as you know, the thing under the radical cannot be negative. It has to be greater than or equal to 0. Therefore, plus 1, x needs to be greater than or equal to 1. So h has a domain of 1 to infinity. Same thing for L. L is a square root. So the thing under the radical has to be greater than or equal to 0. If I add x to the other side, I'm going to get that 5 is greater than or equal to x. So x can be at most 5. So when I look at adding f and h, while f could take any x I can think of, h is a lot more picky. It can only take x's from 1 on up. And f plus h, this thing, can only accept x's that work in both. Therefore, the domain of f plus h is the domain of each component function, in this case f and h, intersected together. Remember, guys, that intersection is overlap, what's in both. Okay, f's domain is all reals. H's domain is 1 to infinity. If I intersect these together, the overlap is going to be everything and 1 to infinity. So the overlap is right here, 1 to infinity. This is the domain of f plus h. Over here, h and L. H once again has a domain of 1 to infinity. L has a domain of negative infinity to 5. Okay? H plus L can only take x's that work in H and L, that work in both. So I have to intersect these two domains together to get that overlap. If we look at a number line here, this is 1 to infinity. This is negative infinity to 5. So the overlap is right here, 1 to 5. That's the domain of H minus L. Also H times L, because it's the same two component functions. Okay? All right. I think that's enough for today. We'll pick this up tomorrow. Have a great day, and I'll see you later. Bye.